In the following example, we're asked to sketch the piecewise function. So f of x equals x when x is less than -3. So to the left of -3, we have the function, basically y equals x, a line, our parent function for a line. So let's first identify -3 here, and that is actually right here. Here is -3. So when x is less than -3, we have our function y equals x. So that would mean we'd have a line that would go, suppose, right through the origin there, and it would continue something like this. Okay, now of course x is less than -3, so we can remove part of this. Okay, right about there. Okay, and let's see here, we'd have an open dot there, and that of course is at the value -3. Okay, so we'd have an open dot, since in this case y equals x, but it's open since x is less than -3. It's not inclusive at that point. Very well. Then let's see, we've got when x equals -3, we are defined at the value of 5. So let's see here, 1, 2, 3, 4, 5, and that is this point right here. So we're defined there. Okay, and then the last part says when x is greater than -3, we have our function equal to the square root of x plus 3 and then plus 2. So that's an interesting situation. What we should do is recall the parent function, and I'll just do a little quick sketch here. So here's our parent function for the square root of x. So the following function, square root of x plus 3 and then plus 2, that's simply a transformation. We're sliding it, let's say, to the right. No, not in this case. To the left. Okay, and then up. So it is a horizontal translation and a vertical translation at the same time. We're shifting it over to the left 3 units. That's where the x plus 3 comes in. To the left 3 units and up 2 units. So if we're moving 3 units to the left, we're going to go 1, 2, 3, and then up 1, 2. So our new point is going to be right here at that spot. So here's our point, and then our graph will simply look the same. Our square root function. Okay, and of course, knowing right about here, and let me fix that for you, that it's not defined. Okay, very well. Okay, and I will mark off the number 5 there for you as well. Okay, so our graph, it's a rough sketch. My apologies for the way that it looks, but it's a very rough sketch. So now that we've sketched it, let's look at the next example. It says, just by observing the sketch above, determine the following values. Okay, we're looking at the limit as x approaches -3 from the left-hand side. So here is -3, and as we're coming in from the left, what are we getting close to? This value right here, -3. So that's what I'm going to write in, -3. Okay. Now as we're approaching -3 from the right hand side. So here again is -3, and we're coming in from the right, and what are we approaching? This value right here, which is, well, it's just 2. So we're going to write 2. Okay. Now let's look at the next one. As x approaches -3. Well, this one is the limit in general. Well, let's look at the left-hand side and the right-hand side. What can we say? Well, the left-hand side is -3. The right-hand side is 2. Okay. Well, let's think about that. The left-hand side and the right-hand side are not equal. So, this limit does not exist. Alright, that's fine. Now, what is f of negative 3? Well, here's negative 3 again. The only place that I see my function defined along this vertical line here is right here at the y value of 5. So f of negative 3 is simply 5. Okay? So this answers our questions in regards to the sketch that we just made.
Made with Doodlecast Pro.